The percentage of adults ages 25 to 35 living with their parents has increased steadily over the past 30 years. The following table gives the year and the percentage of these adults still living with their parents. So what I want you to do is this. I want you to enter your data into your calculator. I want you to enter the years into list 1 and the percentages in list 2, and then take a picture of those two lists on your calculator and include it on the assignment. Take a moment and do that. So here is my data. Notice my data is shaded in yellow, so yours shouldn't. Please include this on the assignment. And now what we need to do first is to create a scatter plot for the data, and then we want to run a linear and a quadratic model in and for the data. So take a moment, create your scatter plot of the data. Remember, the scatter plot is the first type of statistical graph. Include your scatter plot in this box that's included on your assignment. And here's what our scatter plot looks like. And now what we want to do is we want to create a linear model. We want to find the line of best fit and the quadratic model for the data. So first, let's go about creating our linear model by doing some linear regression. What we're going to be doing is we're going to be pressing Stat, going over to Calculate, and down to Option 4. Option 4 represents linear regression. We're going to have our calculator find the line of best fit for the data. Make sure your X list and your Y list match the list that you use for your scatter plot. And now, while the cursor is next to Store Regression Equation, what you're going to do is you're going to press the alpha button, the green button, and then Trace. When you press alpha and trace, the following menu should pop up, and what we want to do is then just press enter for Y1. We want to have the calculator find the line of best fit and then save it into Y1 of the graphing screen. So this is what your screen should look like, and now you move the cursor down to where you see calculate and press enter. And your calculator should give you the equation for the line of best fit. So here is what your calculator should look like. It gives you an A, a B, an R squared, and an R value. Please take a picture of this screen and include it on the assignment. If your calculator is not giving you the R squared and the R, what you need to do is you need to press the Mode button, scroll all the way down to where you see Stat Diagnostics, and then turn that feature of the calculator on, and then repeat the process. Now what I want you to do is press Graph, and on your scatter plot, you should now see the line of best fit. Now this picture need not be included on the assignment yet, but if you look at this blue line, we're trying to come up with an equation that represents the points, and that blue line really does not match the equation at all. And it should make sense to you because if you look at your R value, your correlation coefficient, if your correlation coefficient is in between 0.75 and 1, we say there's a strong correlation. If your R is in between 0.5 and 0.75, we consider it to be a moderate correlation. If R is in between 0.25 and 0.5, we say there's a weak correlation. And if R is in between 0 and 0.25, we say there's no correlation. Now we notice our R value here is a negative value. It's negative 0.359. It's negative because the line has a negative slope. So the negative value just gives you whether the line is positive or negatively sloped, we're really looking at the absolute value of r, which in this case is 0.35. 0.35 is in between 0.25 and 0.5. So we say that this line has a weak correlation with the data. The line does a really weak job at explaining what's going on with our data set. Now what we're going to do, we're going to run a quadratic regression for the data. We're trying to find now a parabola of best fit. And that seems to make sense because the points are definitely in the shape of a parabola. So what we're going to do is, again, we're going to go to Stat, over to Calculate, but now we're going to go down to option 5 for quadratic regression. And that screen is going to look like this. Once again, make sure your X list and your Y list match the list in which you entered your data. Move the cursor next to Store Regression Equation and press Alpha and Trace. But now what we're going to do is we're going to go down to option 2 for Y2. What we want to do is we want to save the linear equation in Y1 to be graphed, the quadratic equation into Y2 to be graphed, so that way we can compare and contrast the line and the parabola of best fit. So while the cursor is next to Store Regression Equation, press Alpha and Trace, go down to option 2 for Y2 and press Enter. So now your screen should look like this. Next to Store Regression Equation, we want to have Y2, and then we want to go down to Calculate and press Enter. Now when you do that, this is what your screen should look like. Your calculator should give you an A, a B, and a C value for the A, B, and the C that represent a quadratic equation, going back to your days with the quadratic formula. And your calculator gives you an R squared value. But notice what's missing, the R value, the correlation coefficient. What we're going to do to get the R value on our calculator is as follows. Go back to the home screen of the calculator, press second and then x squared to get square root. And now what we're going to do is this. We're going to press the vars button, the variables button, the button that's next to clear. When you do that, this is what your calculator should look like. You should go down to option 5 for statistics. Move the cursor to the right twice to equation, and then go down to option 9 for R squared. What should happen is, when you select R squared, on the home screen of your calculator, you should now be telling the calculator to take the square root of R squared, and then when you press Enter, this is going to give you your R value. And in this case, your R value turns out to be 0.987, and then if you round to the 4 decimal places, 4, so 0.9874. What I want you to do is I want you to write down that R value, and then press Graph, and then take a picture of the scatter plot with now both the line of best fit and the parabola of best fit created. This is the picture that I want you to include on your assignment. And if you notice, the parabola really does do a better job of representing the points, the data that were given to you. Now remember, if your R is between 0.75 and 1, it's considered to have a strong correlation. And here our R value is almost 1. It's 0.9874. So we say that this parabola of best fit has a strong correlation with the data. So which of the models has the higher correlation, and what is that correlation? Here we would say it's the quadratic model, and the correlation is that 0.9874 value. Describe the type of correlation. We said it was strong because it was bigger than 0.75. And now what we want to do is we want to answer the question using the better model, so using now the quadratic model, calculate the percentage of adults aged 25 to 34 expected to be living with their parents in the year 2020. So what we're going to now do is this. We're going to go to second and then window. We want to go to the table setup feature of the calculator. And we want to type in for table start to be 2020. So you press second and then window and then table start 2020. And then what you want to do is now press second and graph to get to the table menu of the calculator. Take a picture of your table, and here they say X is 2020, and notice you're given two columns, a Y1 and a Y2. Remember, the Y1 represented the linear model, the Y2 represented the quadratic model. And here we want to use the quadratic answer, which in this case is 29.6. So according to the data, if the patterns continue in the year 2020, 29.6%, so almost 30% of people aged 25 to 34 will still be living with their parents. The next problem, the following table shows the median price in thousands of dollars of privately owned U.S. homes in the Northeast and the South for the years 1995 to 2001. So here they give us the years, which we're going to enter into L1 of our calculator. They give you the median value of these homes for the Northeast, so that's going to be our list 2 data. And then here they're giving us the data for the South, so that's going to be our list 3 data. So take a moment, enter in the data into all 3 of these lists, L1 for the years, L2 for the Northeast, L3 for the South, and then take a picture of that data. Now here's what we want to do. We want to create scatter plots for each set of data. And we're going to be very, very careful in terms of how we go about doing this, because now we have 3 lists. First, we want to create a scatter plot for the Northeast data. So for that scatter plot, we're going to want to use lists 1 and 2. Then we want to create a scatter plot for the South. We still want to include the years, but for the South, we want to include list 3. So here you're going to be doing 2 separate scatter plots. First for the Northeast using lists 1 and 2. Next for the South using lists 1 and 3. Take a moment, take a scatter plot picture for each corresponding set of data and include them on the assignment. Remember, for the Northeast, you're using list 1 and list 2 for your scatter plot. For the South, you're using list 1 and list 3. And this question is a little bit different because what you are being asked to do is create a quadratic model for each region. So we're going to have to run two different quadratic regressions. So first, let's do the quadratic regression for the northeast. So I'm going to stat and calculate and down to option 5 for quadratic regression. But for the northeast, we're using lists 1 and 2 for our scatter plot. Make sure the cursor then is next to store regression equation and press alpha and then trace. And what I'm going to do is I'm going to save the quadratic regression for the northeast in Y1 on my calculator. Go down to calculate. And then take a picture of the quadratic regression for the northeast. Remember, when you do a quadratic regression, you have to give an A, a B, a C, and now we need an R value. So first we're going to go back to the main screen of the calculator by pressing second and mode to quit, second and then the X squared button to do square roots. We then want to press the VARS button, go down to option 5 for statistics, move to the right twice to equation, and then go down to option 9 for capital R squared. Press enter. Your calculator should then look like this. You're telling your calculator to do the square root of R squared. Press enter, and then your calculator should look like this. So the correlation coefficient for the northeast data, the R to 4 decimal places is 0.99. 7 kicks that 9 up to 0 and kicks that 8 up to 9. So the 4-digit R value is 0.9990. I do not want you to graph the scatter plot with the equation. All I want you to do on your assignment is have the scatter plot and then the data for each regression. Now what we're going to do is we're going to do a quadratic regression for the south. So once again, press stat and calculate and go down to option 5 for quadratic regression. But now what we want to do is we want to use the X list is L1, but now the Y list is L3. We want to have, again, the years being graphed, but also now the south data. Move the cursor down to where you see store regression equation. Press alpha and trace. But now what we're going to do is we're going to select Y2. So we're going to have the Y1 equation representing the northeast data and the Y2 equation representing the south. So press alpha trace and then option 2 for Y2. This is what your calculator should look like. X list L1, Y list L3, store regression equation into Y2. Then go down to calculate and then take a picture of the resulting screen. And this is what the screen should now look like for the south data. And now once again we have to go about calculating our R value. So go back to the home screen and have your calculator take the square root of R squared. Remember, we press the VARS button go down to option 5 for statistics, overwrite twice to equation, and then down to option 9 for r squared. So you're going to take the square root of r squared. It's important to do this step immediately following doing the quadratic regression because your calculator remembers the last r squared value. So right now your calculator has this green south r squared in its memory. This northeast r squared is completely gone. It's no longer stored. So now that we have this r squared value in the calculator's memory, follow these steps to go about getting your r value for the south. So here the south's r value is 0.988, and the 6 kicks the 4 up to 5. So notice the both of the r values, the northeast r value 0.9990 and the south r value 0.9885 are both bigger than 0.75, so we say there's a very strong correlation between the years and the data. So now we want to use these quadratic models to calculate the median price of these homes in the year 2020. So the first thing we're going to do is we're going to go to the table set feature of the calculator. You're going to press the second button and then window for table set. And then you want to type in table start, type in the year 2020. And then you want to press second and graph to get to the table menu of the calculator. And here's what your calculator should look like. In the year 2020, if the trends continue, the median price for a home in the Northeast, very, very expensive. This is in thousands of dollars. So this is, if I use my value here, over $1 million. This is $1,189,150. Northeast is one of the most expensive places to live in the country. That's if the trends continued from that older value, that older data. How did I get that? Remember, Y1 was where I stored my Northeast data. And if I look at Y2, where I stored the South data, this particular value, move the cursor over that value and then look down here for the exact answer. So here in the South, the median price for a home, if the trends continue, $428,099.99, because it's in thousands. We have to move the decimal point 3 places to the right. So that's how we use regression analysis to make predictions based on data.